Hello everyone, a very good afternoon to all, and thank you for taking the time to join us today. We appreciate your interest and we are excited to have you with us for this session. Let me start with a simple question. Have you ever felt like your workshop could deliver more, but something is holding it back? Many workshops still struggle with challenges like inconsistent output, material waste, and heavy dependency on manual processes. And as production demand increases, these challenges only become more visible. This webinar is specially designed for startup and small factories who are looking to build a more structured and reliable production setup. Whether you are just starting out or you are already running a workshop and want to improve consistency, this session is highly relevant for you. Reliable production is not just about having machines. It's about how every stage of the process is connected and works together seamlessly. It's about how everything works together, from design to production and final assembly. And that's exactly what we will show you today. A complete workflow, starting from design, moving to panel cutting, then edge banding, followed by drilling and processing, and finally assembly. To demonstrate this, we will be using SmartWOP for design, SAWTEQ S-65 for panel dividing, EDGETEQ S-235 for edge banding, and DRILLTEQ V-200 for drilling and processing. Throughout the session, we will keep things simple and practical. We will explain each stage in terms of what is happening, why it is important, and how the solution ensures consistent results. By the end of this webinar, you will clearly understand how to build a reliable and well-structured production setup. So let's get started with the first step, design. I now invite Sampath to take you through how we create a structured cabinet design using SmartWOP.
Thank you, Sharda. This is the first stage of workflow to design. Here we are using SmartWOP to create a structured cabinet design. Let's open SmartWOP software and start the new project by filling the basic information like company name, client address, project name, and click on the apply to create a new project. Let's start with the base. Enter the base name like cabinet, base cabinet, underscore one drawer unit, underscore one door. So now enter the width, height, and depth. Now the base is ready. Drag and drop the top panel. Enter the panel name, thickness, and the panel offsets. Now we can add 20 mm extra projection for the panel. Similarly, we can add side panels, panel names, thickness, bottom panel. We can also use the arrow mark to lift the panel or enter the actual required dimension for the skirting. Now we have the back panel. Back panel with the panel thickness, setback, the groove required, add the skirting, add the separators for the drawers. Drag and drop the drawer. So we have all the overlay. When we uncheck the overlay, it is inside drawer. When we check the overlay, it is outside drawer. It's a drawer front. So here we have the drawer gaps. All four sides we can give as per the production requirement. Drag and drop the overlay door with the door gaps. Now the construction is ready. We can also add a fixed shelf with the panel thickness, and if there is any setback, we can also give the setback of 50 mm from front. All this can be adjusted using the options. Now we go to the machining. we can select all edges, select the connectors and apply. So that instantly all the edges will be applied with the connectors, minifix and dowels. We can also create a parametric for the connectors. So here we also have the machine collisions. It will highlight with the errors where exactly the collisions are happening. We can select the connectors collision, verify the position. So now it will automatically clear all the collisions. The front distance, on the back distance of the connectors, number of minifix, dowels required. So all those we can preset as a template, or also we can instantly change for each panels. So here we also have the housing side. So now we can just drag and drop the connectors. So you can check the machine collisions now. The collisions are cleared. So before sending the actual production data, the designer can check the machine collisions. So now we also have fittings. We can drag and drop the hinges. So once we drag and drop the hinges, we can control the quantity of hinges, position, hardware CNC machining will be generated, and the costing, manufacturing cost for the hardwares we can export. So here we can also add a cup distance, the right side opening, left side opening. We also have handles. So the handle supplier details, angle, orientation, alignment, all this we can verify. And now we can go to the drawers. So drawers, we also have the tandem boxes or runners like telescopic channels. So all this we have in the fittings. Either we can use from the available hardware fittings, or we can duplicate and create our own custom hardwares. Just drag and drop the hardware. So now the telescopic channels are added. We can now go to the components, drawers, 4-side drawers, drag and drop the drawer component. It will automatically adjust to the available space with the channel depth. Now we go to the material. So material, we can either select panel by panel and change the colors, edge band thickness, or only front different colors, or the carcass different color. So all this we can change it, or just select the frame, select the complete cabinet, drag and drop the material. So now the color is applied for the entire cabinet with the edge band thickness. We can also change with the different colors. And we can also check for the edge thickness, like carcass is 1.3, or for the doors or the front 2 mm. So we can also change all the data. So based on that, our cut list will be generated. So now my complete carcass will be 0.8 and my shutters will be 2 mm. We can also control all 4-side edges, like front visible, a different edge band, non-visible with a different edge band. So all this we can select from the material library. So once the material is applied, now we can also play the animations, open doors, drawers, view in 360, and we can also present in a presentation mode for the customers. Once the cabinet design is done, we can also close the animations. We have 3 different views. One is solid mode with the colors, one is with the wireframe transparent view, and a 2D view. We can save this article as a component so that the dimensions can be parametric. So we can enter the cabinet name, base cabinet, 1 drawer, and 1 door. So this is user defined name we can give as per the production requirement. Now my cabinet is added in the component. Now let's start with a new project. Opening the existing project from the gallery, kitchen, drag and drop the kitchen design. So now we can see the custom kitchen design is already prepared. We can see the animation on the drawer, door opening. So we can play the animations and can view the inside construction. Now we can also create a presentation view with the 360 with the complete kitchen view. So once the presentation view is done, we can close the animations. Now just click on the home, solid mode, and make a transparent view. So let's assume customer wants to replace the 4 drawer cabinet from the left to a single drawer and the door cabinet. So we have created from the existing design. Go to the items. So here we have the separators for the skirting, and go to the gallery, components, kitchen, and the cabinets. Just drag and drop the cabinet. So the cabinet is completely parametric from the component. It will automatically adjust to the available length, width, height. So the color for the shutters, we have to replace it. Just go to the materials, drag and drop the color which is required as per the customer. Select the front, door and the drawer front, and the edges. Just drag and drop the materials. Now the material is added, the complete kitchen is ready. Go to the extras and the explosion. So here we can get the panel numbers which can help for the installation team. We can also export this report as a PDF or image. So we'll get each panel numbers. Just save the order. So now we can export all the reports. Go to File, Export, Cutting List. We can customize the cut list as per the required optimization software, the column alignment, the format. It could be a CSV or it could be a Excel. We can also generate the BOM, the bill of materials, with the complete design preview, the total edge band in running length required, materials, and all the laminate details and the connectors. So connectors will get a complete quantity of hardware, supplier details. And so for example, if you can see the hinges, we need 16 number of hinges from the HOMAG supplier. The hardware channels. Now just export the CSV. So we can see the cut list in a specific file path, which can be predefined. So here we have all the information like panel description, panel numbers, material code, cutting length, cutting width, quantity, thickness, finish dimension, customer name, barcode details for CNC, all 4-side edge band, and we can customize the column details as per the required. The maximum 85 columns can be customized as per the available custom CSV. Now the cutting list is ready. Now we can go to print. We can see the default view, which can be taken as a preview printout in PDF, or we can directly print using printer. Here is the elevation view, the complete kitchen, and also each cabinet level details. Each panel level drilling details can be exported in a PDF, or we can directly print. So now, for the production purpose, we are going to take a single cabinet from the existing complete kitchen design, going to isolate the cabinet, and for this particular cabinet, we going to export the cut list, CNC, hardware list, and send it for the production. Go to export, material list, bill of materials. For this single cabinet, we will get total edge band in running length, in meters required, and the materials, the laminates, and the connectors. Go to export, CSV. You can open the cut list. We'll get the cutting list in a single click. The total required production data like material codes, cutting dimensions, quantity, grain direction, result thickness, all 4-side edge band, CNC barcode details. So the complete information. Now we go to File, Export, Machine. We can select the CNC machine and generate the program for the CNC. The design process is now complete. Over to you, Shraddha.
Thank you, Sampath. So far, we have seen how a cabinet can be designed using SmartWOP in a simple, structured, and connected way. As you saw, the entire design process is clearly defined, where every component, dimension, and connection is already set before production begins. This helps reduce errors and ensures consistency in the next stages. Now that the design is ready, the next step is to move this data into production. This is where accuracy becomes very important, because whatever is designed must be produced exactly the same way. The first step in production is panel cutting, and this is where we will use SAWTEQ S-65 panel dividing saw. To take us through this process, I would like to introduce Suresh, who will be operating the machine on the shop floor. Let's move to showroom and see how cutting is carried out on the SAWTEQ S-65.
Hello everyone. My name is Suresh. Behind me, SAWTEQ S-65 is an entry-level panel dividing saw. Let me explain complete panel processing with SAWTEQ S-65. The production data generated from SmartWOP can be imported directly into the machine. To begin, we navigate to the Nest drop-down menu and select 2D Nest. Here, we browse and select the file that was exported from SmartWOP. Once the file has been loaded, we click on Nest to start the optimization process. The software automatically generates different cutting possibilities based on key factors such as cutting time and material wastage. After the optimization is complete, we navigate to the Auto section. Here the optimized cutting program are available for the production. Depending on the material and the production requirements, we can review the different optimized boards and select the required option. Before starting production, let's take a look at the simulation. The simulation provides a visual representation of the complete cutting sequence before any material is processed. This allows the operator to verify the cutting pattern, review the production sequence, and ensure everything is ready for manufacturing. If required, additional manual dimensions can also be added and processed. Now the cutting program has been verified. We are ready to begin production. The optimized program is now ready. The panel is loaded onto the machine and the cutting process begins with a single command from the operator. This reduces manual intervention and ensures consistency throughout production. As each cut is completed, the individual strip cuts are separated from the panel and prepared for the next stage of processing. At this point, the required strip cuts are temporarily placed aside. These strip cuts will be loaded back into the machine during the next operation, where they will undergo part cutting to produce the final cabinet components. Let us wait till all the strip cutting is completed. The panel is securely positioned using the machine's clamping system. This ensures the material remains stable throughout the cutting cycle. The enclosed cutting area and the safety system help maintain a safe working environment for the operator. The programmable fence automatically positions the material according to the cutting program. Accurate positioning is critical because it directly affects the quality of finished components. The automated process minimizes operator dependency and improves repeatability. The cutting process begins with the board being positioned for production. The first operation is performed by the side pressure device, which moves against the panel and aligns it accurately against the reference position. Accurate positioning at this stage is critical because it forms the foundation for the entire cutting process. Once the panel has been aligned, the main pressure beam closes and securely holds the material in place. With the material securely positioned, the saw blade follows the cutting program generated from the optimization process and begins processing the panel. This helps reduce material waste and improves consistency. As the machine moves into part cutting, the programmable fence automatically repositions the material according to the cutting program. The side pressure device continues to ensure proper alignment of the material, while the main pressure beam securely holds the panel during each cutting cycle. Together, this system helps ensure that every component is produced accurately and according to the original design. This eliminates manual measurements and reduces the possibilities of handling errors during production. The operator guidance system provides visual instructions to the operator throughout the cutting process. It clearly shows when a board needs to be rotated, how it should be positioned, and in which direction it should be loaded back into the machine. This removes confusion during production and helps that every component is processed correctly according to the cutting program. After cutting, each component receives a production label. The label contains important information that helps identify and tracks parts throughout production and assembly. Label formats can also be customized based on specific production requirements. Cutting process finished. The cut and labeled components are now ready for the next stage. These panels will move to edge banding, where the finished appearance and durability of the product are developed. We have now moved to EDGETEQ S-235. This is where the cut panels receives their final edge finish before moving to the next stage of the production. Let's begin by preparing the machine. The first step is loading the required edge banding tape. Depending on the application, different edge banding materials and thickness can be used. For this demonstration, we will load the white edge banding tape and prepare the machine for processing. The glue system is now heating. The glue pot is now heating to the required operating temperature. The glue pot is heated to the required operating temperature and the required processing units are enabled based on the production requirement. The machine also allows operator to load previous saved program, helping to reduce the setup time and ensure consistent results. For this demonstration, all required units are enabled except the corner rounding unit, which is currently switched off. That's because we will first process the opposite edge of the panel. Once the opposite side operation is completed, we will enable the corner rounding unit and process the remaining edges. Now that the machine setup is complete, let's begin production. The panels are now ready for processing. The stoppers ensures a consistent gap between panels as they enter the machine. This helps achieve consistent processing and edge quality across all components. The pre-milling unit prepares the panel edge before edge banding is applied. This process removes minor imperfection created during cutting and creates a clean surface for bonding. As a result, edge quality is improved and the final finish becomes more consistent. The gluing unit applies adhesive to the prepared panel edge before the edge banding material is applied. A consistent glue application is important to achieve reliable bonding and long-lasting edge quality. The EDGETEQ S-235 support both EVA and PUR adhesives, providing flexibility for different production requirements. Once the adhesive is applied, the edge banding material is pressed firmly onto the panel by the pressure rolling unit. The pressure roller ensures consistent contact between the edge banding and the panel edge, creating a strong and reliable bond. This helps to achieve uniform edge quality across every component. The snipping unit, or commonly known as end trimming unit, trims the excess edge banding material at the front and the rear of the panel. This ensures the edge banding matches the exact length of the component, creating a clean and accurate finish before the panel moves to the next processing stage. The trimming unit, or commonly known as top and bottom trimming unit, removes the excess edge material from top and bottom of the panel. This creates a flush and uniform edge profile, ensuring that edge banding aligns perfectly with the panel surface. The corner rounding unit is used to round all the four corners of the edge material. This creates a smooth transition between adjacent edges and eliminates sharp corners. As a result, the finished components achieves a more refined appearance and a premium quality finish. The profile scraping unit further refines the edge after trimming. It removes chatted marks or imperfections left from the previous processing stage and creates a smoother transition between the edge banding and the panel surface. This helps to achieve a cleaner appearance and enhance the overall quality of the finished component. The glue joint scraping unit helps to remove excess glue between the panel and the edge banding, improving the overall appearance of the finished component. The final stage in the edge banding process is the buffing unit. The buffing will polish the processed edge and remove any traces from the previous operation. As a result, the component leaves the machine with a clean and a professional quality finish. The panels have now completed the edge banding process and are ready for the next stage. Let's continue with the DRILLTEQ V-200 and see the next step in the workflow. Let's move to the DRILLTEQ V-200 and see how drilling and processing are carried out. Each panel carries a production label generated during the cutting process. By scanning the barcode, the machine automatically identifies the component and loads the corresponding CNC program. This eliminates the need for manual program selections and reduces the possibility of operator's errors. Before processing begins, we can review the machining program using the simulator. The simulation provides a visual representation of the complete process and shows the estimated production time. It also helps identify potential issues such as tooling mismatches or program-related errors before machining starts. This allows the operator to verify the process and ensures smooth production. The DRILLTEQ V-200 uses the production data generated during the design stage to automatically perform these operations with a precision and consistency. If any modifications are required, the CNC program can be opened directly in Woodwork. Changes to machining operations or tooling can be made here without redesigning the entire project from start. This provides flexibility and helps reduce programming time when adjustments are required. Once the program has been verified, the panel is loaded vertically into the machine. The foot pedal is used to secure the panel in positioning before processing begins. Proper positioning ensures that all machining operations are carried out accurately according to the program. With the panel secured and the program loaded, we can now begin processing. The DRILLTEQ V-200 now perform all required machining operations based on the production data generated during the design stage. Drilling positions, routing operations, and the machining details are executed automatically according to the program. This ensures that every component is processed accurately and consistently. This leads to accurate assembly and faster production. The same process is repeated for all remaining components. By using barcode-based program selection and automated machines, production becomes more efficient and repeatable. All components have now been cut, edge-banded, drilled, and processed. We are now ready for the final stage of workflow, assembly. Let's move to the assembly area and see how all the components come together. We have now reached the final stage of the workflow assembly. Over the course of this session, we have taken the components through design, cutting, edge spanning, and drilling. Now let's see the result. All the components have been produced using the same design data created in SmartWOP. There is no need for manual marking, measuring, or reworking of parts before assembly begins. As you can see, all the components fit together correctly without adjustments. This is the result of the connected production workflow, where the same production data is used for the design through to manufacturing. The cabinet is now complete. Let's now return to Shraddha for a quick recap of today's session.
We started with SmartWOP, where we created a cabinet design and saw how design data can be prepared in a structured way for manufacturing. From there, we moved to the SAWTEQ S-65, where the design data was imported, optimized, and converted into accurately cut components. The cut panels then moved to the EDGETEQ S-235, where the edge binding was applied to improve both appearance and durability of the finished components. Next, we saw how DRILLTEQ V-200 automatically identified each part using barcode scanning and completed the drilling and machining operations required for assembly. Finally, we brought all the processed components together in the assembly stage, where every part fit together accurately without the need for additional adjustments. It's a connected workflow where the same production data used to improve accuracy, reduce rework, optimize material utilization, and create a more reliable production process. Whether you are setting up a new workshop or looking to improve an existing operation, a structured workflow can help deliver consistent quality and dependable results from day one.